Okay. So I will have a talk not about ADSB as an exception probably. I'm going to talk about CPDLC. So ADSB is situational awareness, sending out messages, but you will know more about this than I do. CPDLC is instructions, two-way communications, but I'm not so sure if everybody knows about this protocol. It was invented for different reasons. Now it's still voice communications, clear to take off, clear to land, turn left, heading this direction, and so on. We're using VHF AM communications, which is good, because if one calls and the other one calls, AM makes that you can hear some noise and some signal-to-noise ratio goes lower, so you can just shut up and the next one can talk. But all this appeared definitely in very dense areas, London Heathrow, GF Kennedy, and so on, that it was not possible anymore to do everything by voice. We've seen now air traffic controllers, definitely in remote areas, Finland and so on, they have just monitors and they can switch virtually to different airstrips once a plane arrives. But all this, there are these to have maybe in the future just single pilot aircraft operations, saying two pilots with one pilot in the aircraft and a second one on the ground, which just logs in or helps in the critical phases of the flight. But all this makes the idea to have, instead of talking to each other, just send SMS, just send text messages with a specific protocol. We think in the future with drones and like Amazon, Google want to have package delivery by automated drones or self-sustainable systems. They will also have to talk some kind of language. Definitely if they want to be in controlled airspace. If they're delivering a package just next to the airfield, they have to go into controlled airspace. So what I invented is a CPDLC, and to be honest, it doesn't work as well as hoped. The good thing is, technically speaking, you get a message, it gets in the receiver, it goes automatically to your autopilot, so you just have to push enter and your new heading is in there, and the plane is on autopilot, so it turns to the new heading just by clicking 3 times enter. So very well from a practical use, but like ADSB, it's just no security implementation whatsoever, which is reasonable when it was invented, that it had to be open, since we have planes flying all over the world, how to deal with key sharing and so on, how to deal with limited power available, limited CPU power. So there is this message. And then we're coming out, I think interesting is it's similar-ish to ADSB, because you all can see your timestamps, which we have in ADSB as well. You can see from where to where the plane is going. This type of message, log on request, but it can also be climb to altitude, whatever. This departure airport, destination airport. So I think linking these databases with the existing Open Sky Network database might be even give us more insight in the whole privacy, security, safety of the aviation sector. So what I did, it's very similar than a setup from a ADSB, just a Raspberry Pi. The interface can be SDL, SDL dongle, can be HackerF, whatever, just an interface. Doesn't even have to transmit an antenna, and we used some kind of 3G modem to send out the data packages. So Windows interface, computing power, and the antenna. I have them with me anyway. Every 24 hours we put it to some cloud storage, and through means of a 3G modem. So I had to build my own cloud storage. I know ADSB or Open Sky Network does this professional with huge amounts of data, but we have to start somewhere. So I'm not going to go very much in detail about how this CPDLC works, which is application layer, but it's a little bit over-engineered. It still uses X25 protocol, which is, I think, not anymore used in the IT world for a few decades, probably. So a whole old-school communication protocol. Like I said, nothing encrypted, nothing secret, and there is on GitHub, there are some libraries to automatically decode it even to human readable format, like you saw on the previous slide. So nothing fancy there, and most software exists. And maybe I should say something about VDL2. So CPDLC is the communication, the application data, which actually sends the messages, but it uses VDL2. VDL2 is a VHF network, which is coverage mostly Europe. You can send CPDLC through satellite communications, but in my research, I just used the VHF frequencies. So some kind of reverse engineering of all the messages to split them into different types of message, control messages, content messages. So to make some statistics, I had to start somewhere and creating an SQL database, which I could filter afterwards to see which kind of data there is. Yeah, you see all the tables in the SQL database. I had some good collaborations with Tallinn, where I was living at the time, Tallinn Airport. And I could set up the antenna and the Raspberry Pi for a whole year, for even more than a year, but this message is about 1 year. It was COVID. It was summer 2020 to summer 2021. So not too many airplanes. Tallinn is not the region in Europe where it's so much planes are flying over, mostly from, we had heard before, from St. Petersburg to Kaliningrad, for example. But still we had roughly 4.5 million messages. 3 types of messages: S messages, U messages, I messages. Not too important, but just to know that S and U messages are overhead or keeping the system alive. So only the I messages have this CLNP data. So we're going a little bit higher in the OSI, not even OSI in the protocol stack. So 1.2 messages are theoretically usable of all of them. If we go zoom more in detail about this, it's not working. Oh. So from these 1.2 million messages, even not a lot of them are still doing housekeeping. So we had something COPT data, COPT data acknowledgement to some extent or extended. So we end up with, let's say, roughly 200,000 messages from the 4.5 million that have content. But it gets even worse in the sense of how many actual usable messages we had, and then we go to very, very small numbers. For me, local data authority means just I'm flying from Tallinn to Riga and I change to the new control tower. Wilco is correct message, but it just say, yes, I understand and I will execute. So I think I've mentioned in here, squawk, change your squawk number, proceed to different fixed points, climb to a certain flight altitude, descend, keep a heading of a certain degrees, or maintain position. So if we count those, we're talking about tens, hundreds, maybe a few thousands of them. And still a lot of free text. So the whole idea was we have predefined messages. So we limit the bandwidth. Free text is, you have to encapsulate, write down the whole message because it's free text. But you can see free text definitely from the tower to the aircraft is like 10,000 of more than all the other predefined textures and all. So very limited amount of messages there. And then I had a look in the free text messages, so in this, let's say, roughly 10,000 messages. And they mostly just typed in the predefined messages on different way. So the real use of the free text messages was even not correct. They should have used the predefined messages. So there were, I think, 12 useful free text messages and 8 valuable messages, like, so let's say 20 out of 10,000 were actually useful free text messages. And the downlink messages, which is understandable. Air traffic control is in charge, so they send up instructions to the airplane, and mostly the airplane just says, I execute. Once in a while, the airplane can request for something, but often this is made already in advance in the flight plan, so there's not, unless something happens which was not foreseen. This is going to be a little bit the same as before. So I analyzed the free text messages, like change this call, proceed to some point. This should not be in the free text messages. This should be in the predefined messages. So there's a lot of misuse there in this sense. Like I said in the beginning, I have 4.5 million messages. So I don't think my measurement was good to see if 4.5 million is a lot, is it not a lot? Since there was only one sensor, only one small airport. But I also contacted Eurocontrol and had some good, in fact, some nice discussions with them. They have a paper out, it was paper 2018, but still they measured something with an airplane going, I think, from the UK, flying to Europe and measuring all the messages that were there. But we foresee, after the COVID, and we can see it already now, I think we're already almost at the level from just before COVID arrived, on the number of flights in Europe, or globally probably as well. But so we see that there's, some people expect that there will be a growth, and I think most of the people agree on this one. What we see is even if the channel is not that very much occupied, just a few percent, it's like CDMA, so it's collision detection avoidance, and a lot of collisions happen. So we can see in 2015 on the CSC, the standard channel, where you start to negotiate. CETA and ARINC are the two providers of the ground infrastructure network. Typically CETA is European and ARINC is US-based, but they both doing the same, and there are interconnections between two of them. So they decided to have, once you're on the control channel, to switch to different channels. So even with this very, very few occupation, even with this very misuse, we can see that there was collisions in 2015 of 50% of the messages. Just stating this, that the whole use of the bandwidth, which is foreseen for CPDLC, is going to be congested very, very much if we or not have more frequencies, or we're going to reuse the user messages as it should be and limiting there. But this is probably going to be prohibitive in use. So my conclusions and hopefully further work, that's why I'm here to hopefully join with the ADSB community. ATC doesn't use this at all. Makes sense if the message officially exists, clear to land. But if it can be spoofed, be hacked, and there's no security, who's going to be responsible? So for the moment, VHF voice is the official communication channel, and CPDLC is used as a backup, or it's used on flight level, from flight level 260, I think, by MUAC, by Maastricht upper air level. And if they say change your direction, they have time to see if it actually gets executed. So there's no real rush, no urgent actions to be taken. But if we once go and we enhance the protocol for some reason, and we're also going to say text messages for clear to land and take off and drones, then it will be saturated very, very quickly. Yeah, like I showed from the 4.5 million messages, almost everything went up in administrative and housekeeping messages, leaving very, very few operational usable messages there. I was thinking, but we have to figure this out, and so it's just a Raspberry Pi and an interface, same as ADSB. And a lot of people, I think somebody said this morning, more than 1,000, maybe 1,400 sensors are there. If we can find a way of using the same Raspberry Pi, or maybe we have not enough computing power to do both, maybe we need to have two interfaces. But if the same community can also start to capture this kind of messages, and we can store those messages maybe in some kind of framework from Open Sky Network, it will broaden our view, and it will probably another database we can consult, and we can do some nice statistics and conclusions on. I don't think it will be for tomorrow, but CPDLC needs some security, such as ADSB does as well. I think both protocols, it will just takes time in the aviation sector, maybe not 10, maybe 20 years to have something else. But ADSB is situational awareness. If they actually want to use this as command and control channel, then security is even more important, because then safety comes actually even faster at stake, I think. So this was my briefing. I hope everybody understands now a little bit what CPDLC is. So if you have any questions, please feel free.